Hi, I'm sorry I'm not there again today, but I wanted to give you a little bit of context before I have you do this Desmos activity. We will go into more detail on this later, but I wanted you to be able to explore the concept in Desmos before we did the whole lesson on it. So you're going to talk about vertical asymptotes, holes, and horizontal asymptotes, and we're talking about these on rational functions. So a rational function, remember, is a function that's in fraction form, and their basic graph kind of looks like that. It looks like there's two branches, and they get really, really close to what we call asymptotes. Asymptotes are typically a vertical line. In this case, it was the axis that help assist us in drawing the graph, and they can be either horizontal or vertical. So to find a vertical asymptote, you simply take the denominator and set it equal to 0. So it's denominator, and you don't need to write any of this down, equal to 0. Okay, so I would just take this x plus 6, set it equal to 0. I know that my vertical asymptote is actually x equals, because x equals is a vertical line. So if I were to draw that over here, I would start by drawing my asymptote at negative 6, and then I would draw my two branches of my graph. And they always look like that. They could tilt the other direction as well. The other thing we might have is what we call a hole in the graph. To do that, you have to factor first. So this numerator would be a factor of x plus 3, x minus 3, and then the denominator x plus 3. Do you see what cancels? If it cancels, it's a hole. So I would know x plus 3 equals 0. I set that equal to 0. So at negative 3, I have a hole. Technically, what I just drew was equation of a line. So I'd have the line at x equals negative 3, up 1 over 1. And then when I get to negative 3 in the graph, there would be a hole in the graph. You can't see it when we draw it anywhere. The computer will just wipe it out. But you have to know that when you cancel something, you have a hole. The last thing is, how do we get the horizontal asymptote? So the asymptote that would go this way on the graph. And these you have to compare the numerator and the denominator exponents. So if we had something where the numerator exponent is bigger, so something that looks like x cubed over x squared, we know there is, hold on. Okay, I just wanted to check. All right, so something like this, minus 2 plus 3. So all you're really looking at is the highest exponent. If the numerator exponent is bigger than the denominator, we know that there is no horizontal asymptote. If it's the other way around, I have something like x squared minus 1 over x cubed plus 4. We know that the denominator will grow faster than the numerator, so the horizontal asymptote is y equals 0. And if the exponents are equal, y equals 2x squared plus 3 over 4x squared plus 1. So the exponents are the same on the highest exponent. Then we know that it's the numerator coefficient over the denominator coefficient. Coefficient over denominator coefficient. So in this case, it would be y equals, and I would take these two here and just write that down. So, and of course, in this case, we would reduce that to 1/2. So our horizontal asymptote in that case would have been 1/2. That should be enough to get you to be able to explore the Desmos activity. So good luck, and I will see you on Monday.